Okay, welcome back. So we have here the geometry. So this is what we're going to do, mesh around the sphere and play around with the mesh. And in the video description, you will have the link to geometry and onshape. And also you are going to have the link to download this case. So basically a 3 sphere, you're going to find 3 cases now. A sphere, we're going to work on this one, and then this is just doing the refinement in the background, just to revisit the technique. And pretty much the same here in the sphere. The difference now that in the sphere we don't have any chart angle, so there's no need to do surface features extract unless you want to do this projection of that face. But the hemisphere is just to show you that, let me put it here, just split the face, and there here, okay, you have that nice curvature, but you need to extract that edge if you want to resolve that chart angle. So that's all, okay? You have all the geometries there. And now let's get our hands dirty. So go to sphere and let me close there. So as usual, you have your file. So this is to generate the mesh, and we're going to do the boundary layer addition, okay, after we have the mesh, okay? So remember, that is how I like to proceed, okay? I always, my best advice, do it like this. So here we're generating steps 1 and 2, okay? And then we restart from the boundary layer. So as you go into system, let me open the both files, then everything is the standard as we have seen so far. Just to show you here in geometry, you have the sphere and the wall face to do the projections, okay? That will be the last part. And basically, let's open the standard dictionary. The first part is this one. We do just castellation and snapping, okay? And then we let it to the next step to add the boundary layer. So we want to be sure that everything is correct here, and then we do it here. So we load geometry, nothing new, everything is standard. I'm not going to comment pretty much here. So we have the sphere 2, 2, pretty much, okay, at this point, I think you should be able to do meshes of any geometry. The issue remains boundary layer that I think I will clarify since here, because this is a super easy mesh geometry, and you will see that boundary layer fails. So let me try to demystify some things if it wasn't clear already, but let's revisit. So this is what we have. Look at that, we have this spacing. Okay, this is our background mesh, and we put the first inside and we go. So let's do the mesh. Okay, so this should be super fast. It is not a super nice mesh, okay, so it's a little bit coarse. So let me go here and A3, let me clean here. I move here and there you go. So remember, I have this script. I like to do things very linear. Okay, I don't put any programming, shell scripting and so on there. So you just, as you were typing in the terminal. Okay, so let's wait for our mesh. Okay, so we have a mesh, as you can see, perfect, no problems. Also, in all my scripts, I save the log files, or the output of a snappyHexMesh. My advice is always to say that. And in this simple case, please take a look at the output, and you can start to understand many things. Remember that we talk a lot about what is happening here is that Snap is just revisiting the quality, the mesh quality parameters, and then doing some modifications. So here you can understand many things that are happening. And also I have talked a lot, I verify a lot this 2-to-1 refinement ratio that is very problematic, but it works, okay? So let's move that. We have a mesh, okay? Remember I saved step 1 and 2, and now we can visualize things. So let me open Paraphone. And I think, yeah, you have the folder ParaView, and there we have an state. Okay, let me point to the right, always point to the right direction there. Sometimes I forget to save it. So let me save it. So likely you're going to have it now pointing to your right direction. So this is what we have, the mesh, and see that very uniform, beautiful, the refinement. You can see that all the refinement is done in reference to this one. We choose a refinement of 2, and you can see the 2 levels here. Okay, so original, level 1, level 2, and that's it. Okay, so we're happy here. And look at that, in the process of doing the snapping and all that stuff, look at that, in some regions, you can have these strange elements here, no? So they are not perfectly like these X's there that are very nice. You can have these collapsing elements. So likely that is where you're going to have sometimes problems in the boundary layer, some quality issues and so on. So that can be controlled with in the dictionary, in the castellation options, but honestly, don't invest too much time there changing that. The values that you have by default, the ones that we use, and I think pretty much everybody use, are okay. We have tested a lot. So the solution to that issue is finer surface meshes, that's all. But in any case, feel free to play with that and let me know if you find a better combination. In any case, let's add now the boundary layer. So to our purposes, everything is perfect. Also, remembering when it comes to check mesh, I didn't put it there, but you have this option, all topology, that it will give you more information. So probably later we're going to use this option to show more information when we run the check mesh, and just to show you that it would show you a lot of information, extended information, not the basic one. So see that concave cells, a lot of stuff. So here, don't be afraid when you get some error in those new options. Okay, be careful that the only ones that the most important one is when you run check mesh without these options. Now, so non-orthogonality, aspect ratio, excuse me, but the others, you can play safe now, but sometimes can give you problems. So we have that, and now let's add boundary layer. So I open here, and here we have the definition. So look at that. Now we're sure that we have a very nice volume surface mesh, okay, a volume surface mesh. And now we want to add the boundary layer. So disable, enable, don't care about any of these options. It is important that these are still unique to define. So if you add a lot of cells in the boundary layers you are planning, so remember to increase it here, and probably you can play with those options as well. This is not going to be touched, or probably yes, when in the process is adding the boundary layer. So there, and here's where we add the boundary layer. So we call that patch, that wall sphere. We're going to add 5, relative size is true, and we have all these options that we have already visited. I always, my advice, use the final layer thickness. This is the one that I like, but you have different combinations. So let me go to the Excel worksheet that you can download this from the link. So we have a 0.2 background cell, refinement level, it is 2. Okay, so here we have the progression. So you have final, relative, first relative, refine wall progression, then another progression. But I always use this one. This is a little bit trickier to use, okay, because it's difficult to control. So I prefer to use this one. I will show you why, or let's see why. So here you have your base cell, this is your refinement, and then your surface edge refinement is this one. And what I like to do this one, because the final layer, your boundary layer, you give a percentage, okay? So you say that you want that final layer, that in our case, we're going to add 5 layers, will be 50% of this layer. So you can control very well that transition. Instead in first layer, yes, you can control that, but it's a little bit more tricky. Okay, so I like to use this one, and when I use commercial software, this is my preferred option as well. So sometimes 70 is a good value, okay? So see that all parameters change there, but let's just stick with 50. This is almost my standard. So see that using this value, we're going to grow the boundary layer with this total thickness, okay? Then your in the near wall distance you have here. So this is close to the wall, and this is, see that 50% of this cell. Okay, so you're going to have a very nice transition. You have many parameters here. The most important one that I already mentioned, it is this one, aspect ratio. Okay, aspect ratio in snappyHexMesh, when you start to get values more than 100, is where you have the collapsing. So as you inspect this one, you will see that about probably 22, 23 it is going to fail. Okay, it's not going to be exactly the same value. Probably for the first mesh it will be pretty much spot on, but then it is a little bit obfuscated, convoluted how OpenFOAM Snappy compute this aspect ratio. Okay, so there will be some errors. I know precisely, but there are some corrections and so on. So here I have it in the, let's say, linear way, but there will be for larger values some differences, and it will be due to the corrections, to the improvement in the mesh, so some things will change. But anyways, I know that is here, but for me, they have also a good parameter is this one, 32. When you reach this number here, 32, also you start to get problems. So it's whatever you reach first, okay? This or this 100 here. So usually you reach this one first when you add correction. And just to mention that here, I have this cell here. I put don't use. This is that correction aspect ratio. I know precisely, but leave it to 1, okay? But when you add this correction, let me put, for instance, you put 2 here, you see that you reach it first. So, but for this purpose, let's play like this. And this 32 will be 2 to the power of 5, and it is kind of a hardware limit, not intrinsically in OpenFOAM. In OpenFOAM is this one, but it correlates very well to this one, and it's due to this expansion. Okay, I don't want to go into details, but 5 is going to work. Okay, so let me go here, and we go, and let's do run mesh, and it's BL, okay, and we'll start from 2, and it will add only a boundary layer, this information. So look at, these are the steps. Now cancel tree if it already exists, read the new dictionary, and check the mesh. And there you go. So when you look at this file, 100% coverage, I was already sure. But if you go to the beginning, look at that here, near wall distance, 0.0121, okay, near fall here, you have it, okay? So you can predict that very well. So you can aim for 10 to the minus 6 and values like this, that those are very difficult, and hopefully I will show you in this video to reach those values, okay? So there you go. And then the total thickness, okay, 0.089, okay? You have it there. You have your prediction. And that's it. So let's visualize the mesh. Put it there. I have the state. And let me go here. Open. Already changed it. And there you go. So look at that, what I mentioned, what I like to use final thickness is this. Look at that, it will control it, and you have a very nice progression. So that is my advice, always use final layer thickness. It is easier to control and it gives you better results, but it's up to you. You have different combinations, so play around. And that's it, okay? So what if we want to drill down in this boundary layer and get something way much finer? Okay, so let me go close here, we come back here, and let's go and let's say that I want to aim to 0.001. So I will put 19 layers, and I know that I'm well below 100. This is going to work, almost in the limit of 32, but it's going to work, okay? So let's change here, and let me put 19. Okay, so super easy case, and you will see that in one point nothing is going to work when it comes to the boundary layer. Surface meshing, volume meshing, everything works perfect. So let me stop here, look at 19 layers, 00093. So here we have better put on our progression, and then 0.14 the thickness, there you have, okay? So these are just geometrical progressions, okay, how everything is added. So in theory, you can add one layer at a time, but it's very time consuming. And actually in the ESI version, by the way, just to stress, we're using the OpenFOAM Foundation 12 in this case. ESI have many options, and within those options in the ESI, they added that option to add one layer at a time. But when you reach this, this wall of the aspect ratio, it's not going to work. But it has the tendency to work better. But there you go. We have this. Let's visualize scenes. Close there, load the state. We have this one here. Open. And there you go. Fantastic. Okay. Very simple geometry. Okay. But it's tricky to add boundary layer. And if you try to do something using first layer thickness, you will see that it's tricky. It's difficult to get to grow those layers. That is completely different video. Again, I stress this one, use final layer thickness is the easiest to control and give you the best results. So this looks very, very nice. But what if I want to get even finer? And here's where things start to fail. So let's say now that I want to add 30 layers to get 10 to the minus 4. Okay, so I already know, or probably let's go 25. Okay, this is kind of in the limit, but I know it's going to fail. Okay, I'm already here and already in my linear aspect ratio progression, which by the way, it is the ratio between the shortest distance and the largest one. No, normal to shortest, the distance normal to the wall, and the largest distance in the surface. So here you have how it's computing this one. So you get the near wall distance. Okay, it's very important quantity in Torrance model as well, now to know getting good meshes. So the idea is that you get something below 100, you know that it's a good mesh, no, geometrically speaking. Physics is something else, but it's becoming a kind of a standard practice. So 25, it is going to fail. Actually, I didn't practice this, believe it or not. So let's see if it fails. So let me go here. And look at that, we have the value 0033, so see that, not a problem, everything. And there you go, it failed. Super simple geometry, it failed. Okay, so let's go here. Okay, load state. One, I'll put it here. And there you go. Didn't grow bonded layer. Sometimes I advise you, my advice is to open, okay? Because sometimes that check mesh is lying. It's going to tell you something when you visualize, you have something different that can be better or worse, no? But always visualize something. But in this case, yeah, it's a very bad result, okay? So let's do an exercise. Let me go 24 and let's see which one is the limit when it fails the boundary layer. Okay, so we know that our Excel here, that would work. This one is failing as well. Let me go 23. Okay, so look at here also your quality metrics, no orthogonality, and aspect ratio actually. 286, and look at that, this is very far, we were in 23 from what I have here now. Here I have 100. You see here 2.86, because that is after Snap is doing all the corrections and everything to get the boundary layer, okay? So it's doing the corrections to avoid low quality cells, okay? So that's why you see almost a perfect aspect ratio. In any case, in this case also, I think it will fail. Yeah, no, you see 23, you have a good coverage, okay? 23, 100% coverage. So in our case, let's say that it's almost borderline. Yeah, it's borderline. But yeah, there you go. And if we look at the aspect ratio, let's see what we have here. Look at the aspect ratio. This is predicting 17. Remember previously it was something about 2. In our case, we're about 100. And this is where things are a little bit obscure in Snappy how this is computed. Okay, so it's after corrections, remember. But my advice, no, look at this one. This is the that progression from the surface to the near wall distance. Okay, so you have it there. So here after corrections. So yeah, perfect mesh. 23 cells are our limit. So what if I want to go 30 cells? So if I go 30 cells, I have this one, but let's say that I want 10 to the minus 5. Okay, this is my, whatever reason, my y plus is telling me that, okay, you need this value according to your y plus or your prediction or whatever. So let's go ahead and put 44. I know out of the box, okay, that is going to fail. So let me generate this one. So hopefully you're getting an idea, and let's see here, look at that. We're predicting our value, the thickness and everything. And as expected, nothing. Okay, and you check here, aspect ratio, perfect. Okay, because you didn't grow anything. Okay, so basically that aspect ratio will be equivalent to 1 layer. Okay, so there are some imperfections in this surface, but in any case. So how do we get this boundary layer? And this is where people now fails. And remember, this is it cannot be easier. this geometry, okay? It's this freaking sphere, okay? No edges. So basically, one thing is that you can use first relative one, that is another complete video, I'm not going to address in this one, and then get finer meshes. Always the solution to the problem is finer meshes, and you can get an idea that when you get finer meshes, you're going to control this aspect ratio, okay? Smaller surface cells, you control that, okay? So that is the one of the way. It's difficult to control, and then also very often you end up with extremely fine meshes. So there are other ways to do that. So probably you already recall the easiest one, and if you reread your output, you will see, you will identify where do you have problems now. So most of the time, okay, let me go this way now here. Let's open Mesh Quality Dictionary. Okay, so you have all these quality metrics, but for boundary layer, okay, most common reason for failure is the mean determinant, which is related somehow to aspect ratio and so on. So you can disable this by putting a negative value, or you can use a smaller value. And let's see if it works in this case. Okay, let's put smaller value, and let's see. So as you look at here, you will see that mean determinant is the one and giving problems. So Snap is doing some corrections, and it cannot fulfill this requirement. Everything collapses. Didn't work. Let me put a smaller value. Okay. And see that it still have some problems. Let's see if it works. It's still collapsing there. So probably in this case, let me put another one. It's not the best choice, or probably I can go right ahead and put it negative. Okay, since that is getting better, see that I haven't less and less cells. So when you have these cells, what Snap is going to do some smoothing the mesh and so on, moving cells, and that's why collapsing happening. So see that it might be related to these smoothings and so on. So let's add another 0, okay? And let's see what happens. Remember, you put negative, you disable that, and likely it will work, okay? So let's see, and see that now we found that value, 100%, okay? And you can look, always take a look, take your time, explore this one, try to do your math, or here's more your geometry to get now all this aspect ratio, all these relations, and this, there you go. So paraphone, let's open, let me close here, let me open here, pattern view, open this here, and voila, perfect boundary layer. And as I say, super easy geometry, everything was failing, no, using the standard parameter. So for everybody that says that in the Snap it's impossible to generate this, there you go, 10 to the minus 6. And you can get an idea that you can get even finer meshes, but pretty much 10 to the minus 6, I think it's already a very low value. So you put negative, you disable that, okay? So probably you can go right ahead, but I don't like to use the negative option. No, usually I like to leave this option enable, but probably it's better the negative for complex geometry. In this case, easy geometry, it works fine. Very complex geometry is probably negative is the way to go. But look at that, perfect coverage. At this point, you can go even finer meshes. So just to show you, let's put here, and where? Okay, let's put here, let's say 55. Okay, so 55, probably I don't even have the value here, so but it will be a very, very fine mesh. Okay, so here, let's see at the beginning, okay, 10 to the minus 6. Okay, so this is as fine as it can get. So here I'm having problems, so now it's not the mean ratio, okay, it will be something else. So now probably very, very, very likely I'm going to have negative volume cells and so on. So there you can play with other parameters. So let me put here all geometry, all topology to see what else do we have. And also minus latest time. So I go here. And there you go. So see that you have 8 with negative volume. So these are the culprits, very, very, very likely. Look at that now. No orthogonality is still 68 for such a super fine mesh. This is not true now, and you can see that there is a lot collapsing. This is already telling you that you have a lot of collapsing concave cells. Okay, so you can control that. Just to mention that concave, you can control there. You have those options. So you can put all these negative, and likely it's going to work. In this case, complicated geometries. Okay, there might be better ways. No, you spend more time here and there, splitting surfaces. But there you go. Now we have things working. So let's put here 45. And another option, okay, to grow the boundary layer. So we show here the negative now. So let me go here, that, and this is the original. Okay, oh, we have it original. So let me see that. Okay, so it's not. Let me stop here. Okay, I don't want to extend too much here. We're almost done. So we have the distance 45, and there you go. It didn't grow. You put it negative or a lower value, it will grow. So this is how I like to control this boundary layer. But the other option, remember, also in the snappyHexMesh here, you can disable all the checks. So this entry here, it is the one that is controlling all the checks. So basically here it's going to do 50 iterations to improve the quality, to try to fulfill this. If it doesn't fulfill this, it will get something else, so collapsing different cells. Okay, so as you go here and put 1, do not put 0. Okay, it's not going to work, it's 1 is the minimum. You disable everything, and this is going to work with any mesh, okay? However, you are disable all these tests. Okay, so if you have complicated geometries, very, very likely you are going to get errors. Okay, so be careful. But this is, for me, this is my absolute troubleshooting. Okay, so here I can look all the errors that you're having and so on, and you're trying to fix here, you know, by adding some localized refinement and so on. So remember, refinement is always the solution to the problems. 100% coverage. Okay, no need to show you. Let me go here. That one was 1, and let's put here 55. Okay, let's go. And this we have 10 to the minus 6, and previously it wasn't working. See that now this one is working. Okay, so this one is equivalent to disabling all quality metrics. Okay, all this stuff you disable. However, not always you need to disable everything. So you saw that only by reducing difference what is enough. If you want to stay with this on, okay, previously we saw that this one wasn't enough. So likely you need to change another one. So now my experience, I know that mean phase weight is the other next culprit. Okay, and if this doesn't work, okay, because I know that I have a message in concave faces and so on, go for this one. Look at that, you have a mean volume ratio. So reduce this one, okay, because this one you are limiting. Now this volume ratio cannot be smaller than this one. Okay, so if you have super fine meshes, also very likely this will be one of those other culprits. Okay, so see that here after check mesh, we have this. Okay, this is nothing to well, you have to be Wolřej oriented. I know precisely also where these faces, and we have done that. Well, now let's visualize this. Okay, how to visualize faulty sex and so on. So load state, part of view, go here, and there you go. So everything nice. Okay. So those wrongly oriented pyramids is here. When you have the super fine mesh, you will see that they are very small, okay, and there will be some problems. Now they are penetrating on each other. So you can get an idea to avoid this problem. Well, finer surface meshes. So you make it finer, likely, okay, and you can do. I invite you to do that experiment. Likely this problem, which one was my check mesh? Okay, so let me close here. Let me go cat block check mesh. So likely this check mesh, okay, was BL. This error will disappear, okay? So you make finer surface mesh, or not disappear, probably less faces, and have to be super fine to erase that, but to avoid that error. So this is it. So now you can see how to get super fine boundary layers. There is no problem. I show you two options. Okay, this first one, remember, will be super fine surface meshes and combination with the first relative. That is tricky to control, but there you go. So yeah, play around with this case. There is a lot to do. It's simple case, but there is a lot to do here, and you can understand much better what is happening. So thank you, and see you next video. Bye.